So let's get started, 10 past 2. You're in the track on identity at scale. So we're going to talk about identity management systems. They may work great today for what we do with them today, but as we hook up more systems to them, as we add more identities to them, as we do more things with them, scalability becomes an issue. We'll take a look at some of the problems, some of the scalability problems, and we'll present solutions. Each of the speakers will address a different topic. And I will kick it off with a presentation on federation architectures. So my name is Hans Zandbelt. I work in the CTO office of Ping Identity for Patrick Harding. I'm based in Europe, and I'm going to talk about next generation federation architectures. So first of all, I want to describe what some of the challenges are with federated identity management today. And then I want to jump into 3 possible solution strategies, if you will, that we can pursue. And then I'm going to finish with some recommendations. So let's take a look at federated identity today. So what we do when we create federated connections is we create a SAML connection between an identity provider and a service provider. I guess most of you are familiar with that. And the process is one-to-one, right? We go out, we find the partner that we want to federate with, we determine which protocol we're going to use, we determine which bindings of that protocol, which specific settings of that protocol, the endpoints of that protocol that we're going to use. We exchange that information mutually, we configure our systems, and then it magically works. Well, you know better than I do, it doesn't work. Often we have to go in and fix the problem, and we thought the partner was going to do this, it's going to be something else now. And basically, it's a painful process. But once it's in place, we're happy. But there's updates too, right? At some point in time, your partner will change something in their infrastructure, and it will change the connection that you have with that partner. How do you cope with that? Well, we actually don't have a process today, nor do we have technology in place to deal with that. So that is really painful. More painful than the creation process is the update process, because something breaks and you won't know how to fix it. And you can't prevent it from breaking because you have no process, you have no technology to communicate updates between the 2 federation partners. And especially key rollover is a big problem, right? An identity provider that wants to change his key, his signing key, for example, for the SAML messages, you can change your key, but your partner needs to know about that. How do you do that? Are you going to email your partners and say, well, we're going to change that signing key in the middle of the night, and you make sure that you change the key at the same time? That is a possible solution, but it's not scalable, and it's going to break at some point. So key rollover is definitely one of the most dominant problems here today. So this is what it looks like. It's a painful process to create a connection, and it's a very painful process to update a connection. So the other side of things is I described a SAML connection as a federation connection, but it's this problem of creation pain and update pain is not SAML specific. If you look at other federation protocols out there, like WS Federation and OpenID Connect, they basically have the same problems. Well, some of them have capabilities that help us a bit, but the basic problem is that there is no overarching trust model that we can use. If you compare it to SSL and SSL certificates, we don't have a CA that issues information about federation bindings or federation protocols or signing certificates in the federation world, right? There's no single CA that we can go to that we can trust to provide us updates and information about our federation partners. We all have to exchange this on a peer-to-peer basis, which is totally unacceptable for SSL, yet we do this in the federation world by default. So, and if you look at increasing that number of connections with federation partners, and if you look at the Internet of Things, as was discussed earlier today in the other room, Well, this is certainly no way forward to connecting 25 billion devices by 2020 in a one-to-one fashion. So, and this problem, even though I described it as a federated identity management problem, it doesn't only apply to web single sign-on. Also, if you want to protect your APIs, you have the same trust issue there. How do you authenticate your peer, and are you going to do that on a one-by-one basis, or are you going to make it a more scalable thing? So one thing that I want to point out here is that I think some of you may be familiar with the term trust framework. So this presentation is not really about the trust frameworks where you go and create policies and create business partner networks. This is about the technology that you need to leverage those business partner networks, right? So once you've got the policies in place, what technology do you use to take advantage of that? So this is about technical trust as opposed to behavioral or policies. So this is a picture of some of the evolution that has been taking place in federated single sign-on. So if you look at the red one, you will see that we started out doing federated single sign-on by extending our applications with a piece of federation code, a SAML library or a SAML toolkit, or WS Federation plugin. And we did that for each and every application. Well, if you want to add a connection to a partner in that way, you have to add that connection in 3 different applications. So clearly we had to do something about that. So we scaled it up a bit and said, well, these applications, they run on a single application server or a single framework. So let's go and plug the federation piece into that framework or application server so that all of the applications running in that environment can benefit from that in one step. So that was a bit better than number 1. Number 3, the step that we, for example, as a company did, and some of our competitors have done as well, is to create a separate federation server so that you can hook up multiple environments, multiple application servers, multiple frameworks to that separate federation server, which takes care of all the complexity of creating and managing SAML connections for you. And it allows you to hook up both your Java and your PHP environments to a single federation server. So that makes it scalable to onto a company-wide scale. Now, so the 4th step, and this is where this presentation, what this presentation is about, is to take another step where we separate the runtime processing of federation traffic for applications from the connection management and the trust management. And that is basically the idea that I want to put forward and I want to present some solutions about. Separate trust and connection management from the actual runtime of processing whatever protocol, SAML, OpenID Connect, or WS Federation. And it's about an architectural separation of concerns that we know from the networking world all too well, where you separate a data layer and a control layer from each other so that you can have your traffic on a separate channel from the control channel. And so the data layer in the federation world would be the protocol runtime, processing SAML traffic and doing message encoding and decoding. And the control layer would be about connection management to configure the runtimes so that they can talk to their peers. So if you look at implementing that concept, the architectural separation of concerns, that leads you to the introduction of a trusted shared service where you actually find a trusted third party that you use to provide you with connection information and to configure your federation connections. And that trusted shared service, well, this is a pretty abstract model, right? I will present some more concrete implementations of that in a moment. But it's sort of a trusted third party, like you have a trusted third party in SSL, where you get your material and information from. We need that for federation as well, so that we can scale up what we do today from a one-to-one fashion to a one-to-many fashion. We all trust the same party to provide us with federation information, so there's no need to exchange things on a peer-to-peer basis. And it basically, if you look more closely at it, it shifts the problem up one level. So it shifts the burden of getting the right partner information. It shifts it up to this trusted shared service, so you don't have to deal with it on a case-by-case basis. So that was a bit abstract, but if you look at one of the practical solutions out there, it's a proxy, a federation proxy, federation gateway, federation router. You find different names for the same concept. And what it basically does is you introduce a proxy that processes SAML traffic and creates connections to peers in the middle of a bunch of partners, so that your partners don't have to connect in a fully meshed network to each other, creating case-by-case connections, but you just all create one connection to the proxy, and then the proxy will take care of creating connections to your partners. And so this reduces, for example, if you look at it from a mathematical standpoint, this reduces the number of connections that need to be maintained in the overall system from an m times n to an m plus n number of connections. N is the number of IDPs, m is the number of SPs, and instead of having a fully meshed network, you just have m plus n connections. So less connections to manage, and they're now being managed by a dedicated piece of infrastructure and a dedicated partner who manages that. This is also the way to accommodate for example, for different implementations. If they're not completely compatible, you can hook them up to the proxy, and the proxy can take care of some of the translations that need to be done. For example, if one partner supports the SAML artifact profile and the other supports the SAML post profile, you can hook them up on both ends of the proxy and they will still be able to talk to each other. But you can also take it one step further and do protocol translation. So if you want to communicate with a partner that is an OpenID Connect service provider, OpenID Connect RP, well, and you only have a SAML implementation, being an IDP, you can hook up to a proxy that translates between SAML and OpenID Connect. And this is one of the things that we've been seeing in the wild as well. So this is one practical solution for scaling up things a bit. Of course, this doesn't scale worldwide. A single proxy that processes all the SAML traffic in the world is ridiculous, but it is a solution that is maybe applicable in situations where subsidiaries of a large company, they want to communicate with each other, right? So in a local environment, this is certainly a viable solution. Second solution is to introduce what is called the Metadata Service. And this is more of an example of separating the runtime traffic from the control layer. And this is a model that is also known as multi-party federation or in common style federation, because in common, an organization in the US that works for higher education and research, has been applying this model for the last 10 years with great success. So in this case, the federation operator, a trusted third party, assembles all of the metadata from all of the partners in a single location. So all of the partners, they trust that third party and they download metadata from there and updates from there. So you don't have to exchange information on a peer-to-peer basis. You just go to your metadata operator, your federation operator, and you get your stuff from there. So again, this reduces the overhead of managing connection information from a fully meshed network into connections that only lead to the metadata service operator. Of course, at runtime, you still exchange SAML traffic directly, peer-to-peer. But now you've separated the control layer, the metadata layer, the management layer, from the data layer, the runtime layer, which processes the SAML traffic. So that's the second solution that I wanted to present. Third solution to scale up things is to use self-service. And this is a model that's applied already by most of the big service providers out there, the Googles and the Salesforces. Their customers, they get their own management portal where they configure their own SAML connection back to their identity provider. And that's a nice solution, right? Because now Google and Salesforce don't have to care about that part anymore. That's not a burden to them to maintain 20,000 connections, they've outsourced all of that to their customers. But if you look at it from that mathematical standpoint, you still have the same number of connections. It's just that the burden has shifted from the SP to the IDP. And in SAML, the burden shifts from the SP to the IDP. In OpenID Connect, it shifts actually to the resource provider, because OpenID Connect has a better model for dynamic registration of clients and RPs in itself. We'll take a look at that later. But it's essential to this model, and that's why it has a star, is that it doesn't actually reduce the overall overhead. It just makes it more manageable by shifting the burden to your customers. Anyway, it does scale up things quite a bit. And so if you look at it from a distance, some other speakers have also been talking about the Internet's missing identity layer that we're developing, and it's about identification and authentication mechanisms, about security mechanisms, but it's also about a trust mechanism that is scalable to a worldwide scale. And as part of creating a framework and a system that allows you to create and manage that many connections, we also need to agree on attribute exchange, right? We all know that if you want to create a SAML connection and you've defined how you want to exchange the information, you also need to define what you're going to exchange. How are you going to call the attribute that you're putting in the email address, right? So those kind of things, we can't keep on doing that in a one-by-one fashion either. We need to come up with attribute schemas, as for example higher education already has done, to make that a more painless process. And so I just wanted to call out to that identity layer. It's a security layer, but it definitely would include a federation piece and a trust framework piece as well. So as I said earlier, this is not specific to a protocol, right? Every federation protocol has this concept where one party signs messages that are meant for the other, and you send it to a specific endpoint that is independent of SAML, that is independent of WS Federation, independent of even OpenID Connect. Yet OpenID Connect has a bunch of mechanisms that make it easier to create that technical trust, trust layer out of the box, because it includes mechanisms for discovery and dynamic registration. So this means that one of the parties can take the initiative to push its information onto the other party. So you don't have the mutual introduction problem anymore. That problem is now shifted towards one of the parties, being the SP in this case, who has to register his information with the identity provider. So as you see, this is also the similar scaling mechanism as mentioned in solution number 3. You don't reduce the burden, but you shift it a bit to a party who's equipped better to deal with that, and at least you avoid the situation where both parties have to keep each other up to date of their information. Now it's just one party who can take control of that and register its own metadata and pull down the metadata of the peer. And especially in key rollover, this is a huge improvement over SAML, where those mechanisms didn't exist out of the box and had to be solved by metadata services or federation operators. And so not only OpenID Connect lives up to the premise of being easier to develop, to manage, and to deploy, but it also makes it easier to scale it up to numbers that we haven't seen with SAML before. And so it is not that OpenID Connect on its own is enough to reach that scalability, right? Because even though OpenID Connect allows you to find your peers and to register your metadata, it doesn't solve the behavioral trust problem at all, right? You don't know if you can trust that party, if he lives up to the privacy policies that you require from your partner, right? That's a separate process. That's the behavioral trust problem. That's not solved by OpenID Connect. But the technical trust, that's a pretty advanced framework out of the box that you get from OpenID Connect. And still, in some cases, parties who run an identity provider based on OpenID Connect Sometimes they won't be able to publish their own metadata so that the partners can find it, and you still fall back to a system where you use a metadata service to assemble metadata and to publish that metadata as a trusted shared service again. So even though OpenID Connect has better mechanisms out of the box, you can still leverage each of the 3 solutions that I discussed to create a truly worldwide scalable system. Now, demo, I'm not going to actually do that because I think time is way too short anyway. But if you want a demo of how OpenID Connect works, and we've seen a bunch of them over the course of the last days already, you can come to me afterwards and I can show you how it would work in a graphical way. So what about SAML and OpenID Connect? Do we need to choose one over the other? That's a question that we get a lot from customers and prospects. So I just wanted to take some time and depict the two against each other. So first of all, as I said, the protocol that we use for federation is not really that important, right? That's an on-the-wire thing. It's about technical trust and behavioral trust that is really important in federation, that is difficult to solve, but the protocol itself, that's not really the issue. And so I would not choose between SAML and OpenID Connect because you can run SAML and OpenID Connect on a side-by-side basis just fine in a multi-protocol federation server or multi-protocol environment using solutions like the Proxy and the Metadata Service. There's no need to force all of your partners to use the same protocol. You can do 2 protocols at the same time. Not a big deal if you know how to manage the number of connections in a scalable way, right? And so if you zoom into the differences between SAML and OpenID Connect, well, SAML is WebSSO only. And if you look at OpenID Connect, you get WebSSO, but you also get means for securing your APIs and in the access tokens that it inherits from OAuth. You get WebSSO and API security in one step. So whatever you do to scale up the number of connections for WebSSO, by the same token, you can leverage that information to scale up your API security as well. So where in SAML you had to go out and do a separate thing with WS Security or WS Trust, you get now one standard OpenID Connect that allows you to apply both single sign-on and API security in one system. So that's one of the core differences. The other is, of course, that SAML is rather heavyweight based on XML and XML signatures. OpenID Connect is based on REST and JSON. It's much more lightweight and geared towards the mobile world. It's more developer friendly. Everybody knows that developing SAML from scratch, building your own SAML implementation is a daunting task, and you will make errors and you will be insecure, I can guarantee you. Yet if you want to create an OpenID Connect client from scratch, that's a pretty doable task. The simplicity of OpenID Connect is definitely something that is completely new and differs from SAML. And yet, if you look at the capabilities from OpenID Connect in terms of discovery, dynamic client registration, they give you a great handle to scale the number of connections that you have with your partners. And SAML doesn't really have that. And of course, we can come up with mechanisms like metadata services that will increase the chances that we are able to deal with a large number of connections. But this is not something that is part of the core protocol. And some of you might have heard that people claim that SAML is dead. Well, if you apply scaling mechanisms, as we discussed previously, maybe SAML is not dead at all, because the protocol really doesn't matter that much. If we take care of the connection management issue in a scalable way, then SAML is ready for another era, another phase as well, right? Where it becomes easier to deploy SAML connections because you don't have to deal with the pain of exchanging key material and metadata information. So it's definitely also important to realize that one doesn't have to replace the other. They can both live. So that brings me to the recommendations that I wanted to get across. So we need to not only think about next generation federation architectures, but we also need to think about how we're going to adopt these solutions, right? I've presented 3 solutions, there may be more, but it's important that we get together and decide on which of the solutions we want to pursue within a certain environment, right? And this is not just about federating with your external partners, but also federating with internal organizations, right? If you use SAML within your corporate parameter, and lots of our customers do, for example, well, these solutions that I presented are pretty easy to introduce, right? You don't need to make agreements with partners on how you're going to do stuff. You can just introduce a metadata service within your own organization, and all your IDPs and SPs can benefit from that. That's certainly one good way to start it. And so in the short term, I think it's important to think about the updates, right? Key rollover and propagating changes to your partners. That's a very painful, error-prone process. And if we can do something to fix that, well, that would be great. And in the long term, we can leverage the same infrastructure that we create for this to auto-create connections to your partners, right? So if a partner joins your metadata framework, you can automatically download that metadata and configure a connection to the partner, right? That's one of the options that we have. I don't think it's a very viable option in the short term, but it's definitely something that would be great to have in the long run. And also think about multi-protocol environments, right? For the next 10 years, it will not be only SAML anymore, it will be SAML and OpenID Connect, and we need to think about overarching mechanisms that will apply to both SAML and OpenID Connect to scale up our systems. So one of the basic ideas that I wanted to get across is try and think about connection management as a separate thing from the protocol runtime, right? A data layer and a control layer, and how we're going to create that control layer and where we're going to deploy that control layer. That is a good thing to think about, independent of the protocol. So a global solution, I don't think I've presented one global solution, but a combination of all of these solutions. Apply a bit of self-service for the large service providers, create a proxy in your local environment, and do a bit of metadata exchange between your partners. That's certainly something that could scale up to a far better number than the number of connections that we are that we're able to create and manage today. So that's all I wanted to say today. So thank you for listening, and if you have any questions, maybe there's 2 more minutes, so if you have, any of you have a question, please raise your hand. Yes?
What exactly do you mean when you say about metadata service? You mean metadata service about the services, or metadata about identity service? And what is included in that kind of information?
Right. So from the SAML world, we have the concept of SAML metadata. SAML metadata is an XML document that describes the federation properties of your partner. So it includes the endpoints and includes the key material that your partner will use to sign its messages. And that is a document that you can give to your partner and say, hey, this is how you connect to me. And that piece of metadata, exchanging that metadata, how you would do that, that's the point of this metadata service, right? So that you don't have to exchange it on a peer-by-peer basis, but you can exchange it through a network, if you will. And the same thing goes for OpenID Connect. There's also a metadata format that describes OpenID Connect partners. All right, so thank you. All right.